Hello, friend. My name is Derek Carter, and in this video, this is kind of an important sequence here. We're gonna start talking about functions. So in this video, we're just gonna do an introduction, so how to kind of define and use functions in Python. So in general, functions are a very important topic. This is kind of the beginning of what I would think of as software engineering. So really, when you start using functions, what you're doing is learning how to break a big problem into smaller pieces, so you can gather those pieces together into related modules, and then use that to design bigger, more complex programs. Okay, but we'll touch on some of those. But on this video, we're mostly just going to get into introducing how functions are defined and how you use them in Python. So if you're ready, let's go ahead and get started. So a function is just going to be a group of statements that exist within a program for the purpose of performing a specific task. Okay, so that specific is kind of an important concept here. So I'll jump to these in a bit here, but the key, the fundamental thing about writing good functions is that they should perform one small specific thing, right? So they should be responsible for doing one thing and doing it well. So anyway, a function is a group of statements within a program that performs a specific task. Usually it's one small task of a larger program. So to try and build anything complex, we have to break it down into small enough pieces that we can understand, directly solve, and then we want to combine those small pieces into bigger pieces to get the full solutions. Okay, so what I'm describing here goes by many different names, and it's not just specific to software engineering. So lots of engineering disciplines, you're going to do the same thing in order to design and solve a problem in the discipline. So, you might refer to this as divide and conquer, or the idea of decomposition of a problem into smaller pieces, so into smaller functions. So we might call that functional decomposition. When you break a problem into small functions and then you group related functions together into what's known as a module, you're doing modularized programming. Okay, and Python is a good example of a very highly modularized environment in terms of the set of library modules that it provides you to use. In later videos, we'll talk a little bit about this. So there's many advantages to this, to using functions. So they allow for code reuse. That's probably the most important advantage. So instead of repeating code in lots of places, you can write a function one place and just call it wherever needed. So you're reusing code fundamentally when you're writing functions like this. I encourage you to look at these links here. I'll have these in the video description. So this isn't a primary goal of this course, but these get at the beginnings of what I would think of as software engineering or software design and development. So, take a little bit of time to think about why you might want to use functions and how to write good functions. Okay, I'll talk a little bit about some of those here in the rest of this video. So at a fundamental level, what we're doing with functions is, without functions, you're forced to write programs that are just long sequences of complex instructions. Okay, so you might have while loops and if conditions and things, but it's just a sequence kind of from top to bottom with maybe some loops and stuff thrown in. So when you have functions, what you would do is you would break these down into smaller pieces and group them into functions. Okay, and it's not exactly shown here, but you would call these instead of executing all these statements in sequence. And some of these might, for example, if you were having to repeat some group of statements, repeat it 1, 2, 3 times, you might group that into a function and then just call the function instead of copying and pasting your code, right? So so if you read some of those links I gave you about why use functions, these are some of the benefits that are discussed and also discussed in our textbook. Right, so I was touching on that you don't have to repeat or copy paste code, and that's related to kind of a similar idea to code reuse. So if you can define a function as one small specific task, then you can just call it whenever needed. You can reuse it over and over in many places, right? Same with a module, which is usually thought of as a group of related functions. And that improves the readability and makes your code simpler whenever you break things down into functions. Okay, so when you're reading code that's been decomposed into functions, the functions act as higher level concepts. So you don't have to understand the details or read the details. You just understand what it's supposed to do. And if you need to, you can always read the code of the function itself to figure out the details about how it actually does what it does. Right? But when you're reading code, if it's broken down correctly into functions, it makes it much more readable, much easier to understand the complexity of a program. We're going to be using testing a lot in this class. So when you have functions, you enable easier and better testing of these pieces that you break into functions. It usually helps speed up development of application programs. You don't have to reinvent the wheel, so you can reuse modules or functions that have already been created. You can, and these two are related. If you're working with a team, you can usually break it up, and one member of the team does this module or this set of functions. This team member does another set of functions, and so on. So break it up, not only breaking up the program into, decomposing it into functions and modules, but then those are smaller pieces that are easily assigned to developers that can implement them in parallel in an ideal situation. So let's look at our first simple example of defining a function in Python. But before we do that, let me just define these two terms. So most programming languages define functions that will return a value, right? But a lot of programming languages allow you to define a function that doesn't explicitly return anything. So you can call the function and it does some work, but it won't return an explicit value. So those have various names, but they're often, probably the most common is they're referred to as void functions. So the only difference between void and value return functions in Python is that a void function just doesn't have a return statement to return a result from calling the function. Whereas a value, the more common thing, the kinds of functions that you'll mostly be writing in this class and normally be writing are functions that do a calculation and then return a result. So they're kind of related to, similar to the idea of a mathematical function, which is takes some input parameters, does a calculation, and maps the parameters to the output of the function. Same thing happens with a value returning function in a programming language. Is we pass it in some input, and it's going to do a calculation and return a result using a return statement. So you've actually run into some built-in functions that are value returning already, like the input, the int, and the float function. So a quick reminder, for example, for input is a function that takes a string as input. So the parameter here is the string, give me a value. So we're passing in one parameter, and it returns a string as a result. So you've seen input used a lot here, right? So if I type in something, that is actually, so input is a value returning function. It actually returns a string, right? And I can't remember, but I think we've used like ints and floats. So if I do this, and I enter in like a value like 55 that can be converted into an integer value or a floating point value. So x is still a string here, right? But if I use, like, let's say int, so int again takes one input as a parameter. It expects a string as input, and x is a string, and it's going to return an integer value. Right, so you can assign. I'm jumping ahead here a little bit. You can assign the result if it's a value returning function into a new variable. Right, so now since I use this value returning function, it actually converted it to an integer and returned it, and I assigned that to y. But y is not a string. It's actually an actual integer, an actual numeric value. So those functions, input and float and int, are actually built-in functions, and you've seen those, even if you haven't known exactly what you were doing with those. But you can define and call your own functions in any programming language, including Python. So usually there's three things that you need to define a function. So you have to give it a name. And again, I'll put this link in the video description and in our course additional resources. But, one of the arts of being a software developer or a software engineer is you really need to give good names to functions. That really helps code readability, right? So good function names should be descriptive. So that means they're usually a verb. We'll get some examples of that, right? So besides the name, functions will usually take some input. These last two are optional here, but if a function takes some input, you have to define what are the inputs. These are called parameters that you pass into the function for the function to use. And then likewise, if the function is a value returning function, you need to determine or know what the value is it returns and what the type of the value is that gets returned from the function. So real quickly, this is what it looks like to define a function in Python. So this is an example. This is a void function, and it's not taking any input. So we're not doing step 2 and 3 I talked about. We just have the name, right? So the name of the function is message. If you have no input, you still have to have the open and closing parentheses, but you don't put anything in there to indicate that there's no input parameters coming. The colon, again, you should think of this as a block. So the statements after the colon are what are going to be executed if we call or invoke this function here, right? So we've got the colon before our usual block of statements that are invoked when we call the function. And then we have the keyword def. So def means that we're defining a function here, right? And since we don't have a return statement, this is a void function. It's not returning anything. And if you want to call a function, so if you want to actually invoke a function, you have to know the name. You have to know what input it takes, if any. So this function doesn't need any input, but again, the parentheses are not optional. So even if you have a function that has no input, you still have to have an empty open closing parentheses. And if it's a void function, nothing's going to be returned from here. But if it's a value returning function, you might want to do something with the value that's returned here. So, we could do that interactively. This needs to be a block after the colon. So, like if I'm doing this interactively or if I'm doing this in code, I need to have my spaces, my 4 spaces, to indicate that this is the block that is the statements for my function here. So print I am Arthur, and they need to be indented correctly, the same each time. King of the Britons, right? So so here I didn't have my indentation matching correctly. So let me try that again. So, just a second. So, that's a good example of things that might confuse a beginner, but they can be confusing. So, you can't mix tabs and spaces if you're doing stuff interactively. You couldn't actually mix tabs and spaces, although usually if you're using an IDE correctly, if you are doing tabs, it'll convert it to spaces. 4 spaces as defined by the PEP8 here. But yeah, I did a tab on the first one and I was doing 4 spaces on the second one, so I was getting a mismatch of the indentation. So as long as I use 4 spaces every time or tabs every time when I'm doing it interactively, I should be able to define my function like that, and I should be able to call it, invoke it by just giving the name and giving any input parameters if there are any, or just an empty open and close parentheses. And there's no return result, but as a side effect, the results of the prints are going to be showing up on my terminal since it's invoking the print function inside of the message function here. Okay, so we probably already covered all these. So we showed defining the function and calling the function. So if you want to call a function to execute it somewhere else you don't use the def. So the def keyword is only when you're defining the function. When you're calling a function, you just need to know the name and the input parameters. And to successfully use a value returning function, you have to kind of know what it's going to be returning from you in order to do something with that return value. We'll see some more examples of value returning functions later on in later videos here. And to reiterate on this, I had problems with my indentation when I tried to do this interactively. And we've touched on this before, but blocks in Python are defined by indentation instead of like curly braces, as is used in many other C-based programming languages. So in our class, we followed the PEP8 style guideline, which means you should always use spaces, never use tabs in the files that you create, and you should always use exactly 4 spaces for every level of indentation for your blocks that you're defining, your code blocks you're defining. So idle or correctly configured IDE like VS Code or PyCharm will do that for you. Will automatically always convert tabs to spaces and use 4 spaces. Although you can usually specify that, but make certain you set it to 4 spaces if it's not doing that for you already. And a few more thoughts again about the importance of functions here. So in this chapter here, in this video, we're getting into the beginnings of software engineering using functions to decompose a problem and solve, build a complex application. All right. So, there's lots of names for these kinds of concepts, but usually when we're trying to build a complex program, we're going to use some sort of a top-down design where we take the big complex problem, try to break that into smaller sub-problems, the pieces that are hopefully smaller and easier to solve, and then we can combine together to solve the original problem. But even those sub-problems in something that's complex are still going to be too complex, so you just keep doing that. Right, so take a sub-problem, break it into sub-problems, and down till you get to something that's small enough to understand and directly program as a function. Okay, in flowcharts, a top-down design will normally be represented by one of these boxes with the 2 vertical bars on that. So that means we're actually calling a function. And so when you call into a function and return from it, that itself is just another flowchart that you're jumping to that implements the function, then returns back and continues execution from where you called it. Okay? Also, I'll just mention quickly, the textbook introduces the idea of hierarchy charts here. We'll talk about these some more later on in the course. These are another thing that you might create when you're designing a complex software system. These really just give the relationship between a function and the functions that it calls. So normally a hierarchy chart is going to give you a relationship between top level functions and then sub-functions that are used by the top level, and then sub-functions and so on. So this, in general, the hierarchy corresponds to the level of abstraction from your very abstract top-level functions that are solving high-level concepts of your program down to the things at the very leaves or the bottom of this sort of hierarchy chart will be the specific functions that are doing one small detailed thing. Okay. Just as one final example, this is the example from our textbook of the sort of functional decomposition and how it kind of works in theory. Here we have a representation of a complex problem, sort of trying to fix some sort of appliance. So we might decompose that into several functions, the several steps in doing the things in order to fix the problem on this appliance that we have here. Right. So here, this often happens. I mean, the main function is usually going to be the top level of your program. That's the start, and it's going to call the other sub-functions to solve the problem, that you decomposed your solution into. Right? Step 1, 2, and 3 might not be really great names. So again, I refer you to some of the links I'll give you about good names to make readable code. Right? It makes a little bit of sense in this example because this is step 1 to fix the dryer, unplug it from the wall and so on. Right? And so in this case, we only do one invocation of the main function, then the main function invokes the other function, step 1, step 2, step 3, step 4, right? And you'll see if you run this example here that main is invoked is the only thing. Is everything else is just a function definition. So the first thing that actually happens is we invoke main. It actually jumps up here and starts running this code. Main then is invoking these other functions. So it calls startup message, which gives this first code, this first print statements here, and then we wait to to press, and then we'll give the step 1 message and so on. All right, so in summary, in this video, we gave an introduction to how to define and call functions in Python, as well as touching on a few other big topics, how functions are the beginning of what I would think of as software design and software development. So a function is a group of statements that exist within a program for the purpose of performing a specific task. Right, and they're a group that can be reused and called multiple places, anywhere that's needed in a bigger program. So functions have lots and lots of advantages, right? So if you're not using functions correctly, you're not doing good software application development. So they make for simpler code. They allow for good code reuse. They allow it to better test your code and debug it. And they usually improve the speed and ease of software development in practice. So functions can be either void functions or value returning functions. So we will mostly use value returning functions for a lot of our assignments and things. And in general, void functions are more of a beginner thing. But when you're writing real programs, you're usually going to be writing functions that take inputs and return some result from doing a calculation on those inputs. So to define a function, you kind of need to define or use a function. You need 3 things. You need the name of the function, to invoke it. You need what input it takes, if any. So the list of input parameters to pass into the function. And if it's a value returning function, you have to know what the type is of the value or the values that it's returning. So you then can use the result from calling that function. Okay, so that's it for this video. As usual, I hope these are useful for you. So stay tuned for the next one. We will get into the details, some more realistic examples of using functions and how you pass in parameters and return results from functions.